Okay, in the second part of this screencast, let us see the example of linear block codes. Consider a 6, 3. Here 6 means n and k is 3. So 6 means it is the length of code word. So the length of each code word would be 6, and the length of each message would be of 3 bits. So 6, 3 linear block code is defined by the generator matrix. So you will be given a generator matrix as such as shown in the figure. So where G is equal to 1 0 0 1 1 0 0 1 0 0 1 1 0 0 1 1 0 1. So this generator matrix is made up of two parts. The first part is you can recognize this first part. This is identity matrix of 3 by 3 size. So 1 0 0 0 1 0 0 0 1 is the size of the first part of this matrix, and that is the identity matrix. In the second part, 1 1 0 0 1 1 1 0 1, this is the parity. So this parity is shown in this figure. So in this matrix, so you may find this is a parity, and you have to find out P transpose. So P transpose is determined. Now how to find out P transpose is very easy task, and you must be knowing this. That is, you have to just exchange rows for the columns. So 1 1 0 is here it is row, and it is made a column in the P transpose. So rows are exchanged for columns, so to get the P transpose. Now why are we discussing about P transpose? Because we have to find out the H and H transpose. So first of all, I'll just explain what is the need of generator matrix. The generator matrix is required because you have to find out the linear block code words from the message bits. So how many messages will be here will be there in this example? It depends on 6, 3. This length. Here 6 is n and 3 is k. So 2 raised to k. Now if you take k is equal to 3, then 2 raised to 3 means 8. So there will be 8 possible messages, and these 8 possible messages are then converted into 8 linear block code words. So you have to first of all find out the linear block code words using this generator matrix. Okay, so generator matrix is given. P is known from the generator matrix. Then P transpose is find out. From P transpose you can determine H. H is the parity check. So how H is determined? Here H is equal to P transpose and identity matrix of size n minus k. So this P transpose is taken here. The first part of parity check matrix is the P transpose, and the second part is the identity matrix. So identity matrix of size n minus k, that is 3 by 3. Now here one example is given, that is how code words are determined by using generator matrix. So with k is equal to 3, you will have 8 possible messages from 0 0 0 to 1 1 1. Here only 2 code words are explained, how code words are calculated. All such code words are written in this column. Let's take first message, that is 0 0 0, and this is your generator matrix, which is there as shown here in this figure. So there is a matrix multiplication of these two things. So how do you multiply this? First of all, if you take the first bit of message, that is 0, so here 0 is multiplied by 1. It means it is simply multiplication of rows and columns. So for row, first row, first column, row, second column, row, third column, and so on. So if you multiply this row and column and add those multiplications, because there will be 3 multiplications, 0 into 1, 0 into 0, and 0 into 0. So 0 multiplied by 1, it becomes 0, 0 by 0, 0 by 0, it is 0. So addition of these 3 multiplications, 0 1, 0 0, 0 0, addition is 0. So this is the first bit of your code word. and you can find that as the first three rows or the first part of the matrix is identity matrix, so the first three bits of the code word will be same as that of the message. So these 3 bits and these 3 bits must be same. The remaining 3 bits are the check bits. And how to find this check bits? The same thing is there, that is the row is multiplied by the column for 3 digits. So 0 into 1, 0 into 0 and 0 into 1, and addition of all those multiplications. So 1 into 0 is 0, 0 into 0 is 0, 1 into 0 is 0, so addition of all zeros is 0. So okay, so for message 000, the code word must be all zeros. Now let us take another example of message 001. So in case of 001, the first 3 bits of the code word must be same as that of the message. So if you can see that 001 is the message and the first 3 bits of the code word are 001. The remaining 3 bits are just find out like by using multiplication and addition. So 0 multiplied by 0, it becomes 0, plus 0 multiplied by 0, that is 0, so 0 plus 0, and 1 multiplied by 1, that is 1. So 0 plus 0 plus 1, it becomes 1. So fourth digit of the code word is 1. Okay. Now the fifth and sixth, the same procedure is followed for all such messages, and you can find out the code words which are as shown in this column. So this is very simple procedure to find out the code words. So up till now the operation of transmitter is over. Now let us move to the operation which is done by receiver. For that you should know H transpose. How H transpose is obtained? By using H. H is already determined. H is P transpose. First part is P transpose and the second part is identity matrix. Okay. Then rows are exchanged for column to get the H transpose. Then to detect the errors, now in this particular example we are just looking for the detection of errors. Error correction is not done in this type of this particular example. Error correction can be done by using table lookup array, which will be discussed in the subsequent lectures. So the syndrome for general received word in general, this is the received code, and this is H transpose. So multiplication of received code and H transpose gives syndrome, and if the syndrome value is 0, it means there is no error. Let's have one example. Suppose your generated code word by the transmitter for message 111 is 11100. It is transmitted by a transmitter, but due to some noise or errors, the 6th bit is errored. So instead of 0, the 6th bit is 1. So your received vector may be 111001. Okay. So you have to multiply this received vector by the H transpose to find out the syndrome. Now the receiver does not know where is the error. Receiver only knows what is the received vector, and it multiplies the received vector by the H transpose to get the syndrome. Once it gets the syndrome, it compares the syndrome value with the pattern of the H transpose. If you see, the syndrome is 001, and this 001 is available at the 6th location in the H transpose, 001. So it means the error is in the 6th bit. So it just detects the error at the 6th bit of the code word. Okay. So in the similar way, you can determine the syndrome for all such error patterns. The code word may be anything, any code word. If error is in the first bit, you will find the syndrome is equal to 000. Got it? Or the syndrome you may get 110, because for all zeros syndrome will be 0. So if the error is in the second bit, you will get syndrome is equal to 0, 1, 1, and it matches the second row of the H transpose. So detector detects the location of the error, and it tells transmitter to retransmit the signal or message. So this is the way through which you can detect the errors. So you may be able to solve such examples where you will be given just a generator matrix and the size of the code words. So suppose there is a 7,4 linear block code. What would be size of G? G would be of size 7 columns and 4 rows. Okay. So with the help of this example, you will learn how to solve, how to generate the code words and how to find their syndrome values. So this is the very basic linear block code, and which is used to detect the errors in the digital communication system.